Nearly gonna start. I'll give 2 more minutes just to give everyone the resources. Remember, they're all just by here. There's notes booklets for you to type things in or write things in. Um, and we're going to be moving on to calculating acceleration today. Okay, so let's calculate acceleration. But first we have to define it. So the word acceleration or accelerate, I'm sure would be sort of a common word that you guys may have heard of before, just as a common usage of, whether you're accelerating, decelerating. These words are also in common language, not just limited to physics. So you might be coming in with already a little bit of background understanding as to what acceleration is and what deceleration is. But now we're just going to put that background understanding into a specific definition. And it's not going to be far off of what you probably already understand about it. First, just as a quick recap, we previously had a keyword that we defined, which is, let me put a keyword that we defined, which is velocity. And remember, velocity is basically just a speed in a particular direction. So you can think of velocity as like change in displacement, which is like just a distance in a particular direction, over time. So it's like a change in a distance from your starting point over time. That's what velocity is. Acceleration is a step above that. Acceleration can be defined, let's do a darker color, as the change in velocity over time. And velocity, remember, is just speed, but in a particular direction. That's it. So it's a change in this velocity slash speed with direction over time. So if you're changing your speed, if say you're in a car and you're speeding up or you're slowing down, you have a bit of acceleration because your speed is not constant, it's not the same, where you're not going at a steady speed, it's changing. But I also want to point out, remember, we're going back to scalar and vector now, and we have talked about this before if you watched previous videos. All the way back in the forces topic, we introduced scalar and vector. Remember, scalar is a type of quantity that only has magnitude, so only has like a number of how big it is, how big or small it is. But vector is a number that has a particular direction to it as well. So like, remember, force is a vector, velocity is a vector because it's a speed with direction. So velocity, direction matters, therefore it's a vector. And because acceleration is a change in velocity over time, it's also going to be a vector quantity, which is why it was so important to define that it's not a change in speed over time, it's specifically a change in velocity over time. Even though, speed and velocity are similar, there is that slight difference, and that slight difference is whether or not we care about the direction. That's it. So I don't want you guys to overcomplicate it in your head and think that speed and velocity are entirely different things. No, they're the same thing. It's just that in velocity, we care about the direction it's going as well. That's it. And because we are using velocity in acceleration, we care about the direction of acceleration. And we have a unit of measurement for acceleration. I'm just going to show you where we get this unit from because a lot of students get confused by this unit. So I'm going to write on the side here just to show you where this unit comes from. So remember we measure speed and velocity in meters per second, m/s. Also could be written like that, but we don't really commonly write it like that because otherwise it takes like 2 lines instead of just 1. So m/s, meters over seconds, that is our unit for velocity. And because acceleration is change in velocity over time, it's meters per second. So it's over a second one. The way we write this to make it like not disgusting looking like that is m/s squared. So basically we're just saying there's 2 lots of seconds in our denominator rather than it being just huge like this. So it's meters per second squared. One big mistake, I'm just going to tell you what the pitfall a lot of students make. One big mistake that I notice when students use the unit for acceleration is that they get a little bit confused by this unit. This is just the unit, this whole thing. A lot of students overthink and think you have to do something with the squared, like square root it to take it away or something like that, but no, you don't have to do any of that. So for example, if I said calculate the acceleration of something something, and you ended up with a correct answer of 5, the unit is just meters per second squared. I have seen many times a student get like tripped up over the squared and then try to like square root the 5 and then give their answer that way. But no, you don't need to do any of that. This whole thing, m/s squared, is just the unit. That's it. You don't need to do anything with it. Just recognize that m/s squared, which is meters per second squared, is the unit for acceleration. That's what it is. Now, we have an offshoot definition. So basically, deceleration is another keyword that I want you guys to be aware of. Deceleration is acceleration. It's the same thing, but it's just a specific type of acceleration. So acceleration is the overall word that we use to represent a change in velocity over time. That's it. But what if this change is negative? So what if you are losing velocity over time, aka slowing down? Like you started with 10 meters per second of velocity, then you ended up on 5 meters per second of velocity. Well, you slowed down then. The acceleration would be negative. And so deceleration is basically slowing down. And all it is just a negative acceleration. So it's still the same thing, but a specific type of acceleration. Here's how this is relevant to, say, like a question and an area where you might get a bit confused. So say a question says, calculate the deceleration of this car. This car slowed down from 20 meters per second to 2 meters per second. Calculate its deceleration. Well, there's a formula we're going to talk about later for acceleration. And a lot of students might get a bit confused where they go, hang on, I know there's an acceleration formula. I know that one, but I don't know a deceleration formula. Miss never taught us a deceleration formula. I never learned that in school. Deceleration formula, don't know it. So I'll give up on that question. But that question was basically asking you to calculate acceleration. So any formula for acceleration, you also use for deceleration. Don't think that they're two separate things. They're the same thing, except deceleration is just specifically when you're slowing down. Okay. So just a quick point I want to make to the higher tier students. This won't take very long. Let's say that we had a circle. Use a different color, a sharper color. Let's say that we had a circle. And we had a little particle or a dot or something moving around the circle. So drew this there, moving around the circle by here. So it's moving around until it reaches its starting point. We call that circular motion, obviously, because it is an object moving around a circle. Notice that it's constantly changing direction. So it's going like to the right here and then going down and then going to the left and then going up. It's constantly changing direction. So this is just a quick point to note that the difference between scalar and vector. In the case of the speed, if this was just moving at the same speed, that is entirely possible. Let's say it's moving at the same speed of 5 meters per second, and it could do that the whole way through. But even if it's moving the same speed, because it's constantly changing direction, it's not going to be moving at the same velocity the whole time, because it's constantly changing direction. And remember, with a vector quantity such as velocity, we care about its direction. So its velocity is changing, and therefore its acceleration, it's accelerating because of it's changing in velocity. If it just had the same velocity the whole way through, we would say it's not accelerating. Acceleration is 0. But because it's if there's ever a change in the velocity, there has to be some measurement of an acceleration there or a deceleration. Now let's look at the formula. Here's our formula for acceleration. We have A equals V minus U over T. So I'm going to label what all of these letters mean in this formula. Let's start off with what A is. A, I hope you guys can imagine, because this is the acceleration topic, that A stands for acceleration. And remember, this could also be a deceleration. With deceleration, you still use this formula, because deceleration, it is just an acceleration, but specifically slowing down. And its unit of measurement that we use is meters per second squared. And remember, this whole thing is just a unit. You don't need to feel like you need to change anything with it because it's a bit off-putting. It's not like our usual units where you just have one neat little letter. Don't worry about it. Just remember m/s squared is just a whole unit for acceleration. So whatever number you get, you don't have to worry about square rooting it or changing it or anything like that. Okay. Now I'm going to go from the bottom first, just because t, you might be familiar with what t might be. Because acceleration is just change in velocity over time, t stands for time. And the unit that we use for time, look, m/s², meters per second squared, our unit to match up with acceleration's unit is going to be in seconds, or s. Now here's the now here are these new letters up here. We have v and u. So remember that acceleration, it's just change in velocity over time. So v minus u is the change in velocity. Now the way we calculate a change in velocity is like, for example, say a car started at 5 meters per second, started moving at 5 meters per second of velocity, and then accelerated to 10 meters per or 15 meters per second of velocity. So start off at 5 meters per second, then move to 15 meters per second. Well, the change in velocity then, you guys probably could calculate, would be 10. It went from 5 up to 15, so change is 10. But putting it into a context of a formula, what you guys quickly did in your head then, in order to get the number 10, going from 5 up to 15, is you did 15 minus 5. So what v stands for is final velocity. So basically, what is the velocity it ended up with? And that is measured in meters per second. And u is the starting velocity. So at the start of this question, what was the velocity of our object at the start? So we have our formula. Acceleration is the change in velocity over time. And to calculate a change in velocity, you take your final velocity and subtract your starting velocity. Now this is where it makes sense when you get a negative value for acceleration. Because imagine if our final velocity was 5 and our starting velocity was 10, meaning it slowed down from 10 to 5. Well, then you end up with 5 minus 10, which is negative 5. And so you end up with a negative acceleration. This is still okay. I don't want any of you guys to get freaked out if you have a negative acceleration, because all that means is that it's slowing down. Okay, let's do an example. A car is moving at a velocity of 28 meters per second, brakes and stops in 8 seconds. Calculate its deceleration. So once again, the problem says deceleration, but we are still going to be using the acceleration formula because they're the same thing. Okay, so as always, if you watched any of my other videos, make a list of what you know. That's the very first important thing that we need to do. A car is moving at a velocity of 28 meters per second. So when it says is moving at, that's probably the starting velocity, isn't it? So starting velocity equals 28 meters per second. Brakes and stops in 8 seconds. So time it took to stop was 8 seconds. Here is one tricky bit of this problem. It doesn't tell you the end velocity. It doesn't give it in a number, but it did tell you it in the form of the question. It said that it stopped. So what that means is that even though it did not say the final velocity of this car was 0, because the question says it stops, you know that the final velocity of the car is going to be 0 because it stopped. So I'm going to write that down. That's just one little tricky bit for you guys to keep in mind, that sometimes when it comes to acceleration questions, they might not straight up tell you final velocity is 0. Or they could say something like a car started up from rest. Well, it didn't say starting velocity was 0, but you have to be able to work out yourself. Well, because it was at rest, the start was 0. If it said it stopped, that means the final was 0. Calculate its deceleration. So deceleration equals question mark. Right. Now, FIFA method, formula, insert values, fine-tune, answer. First things first, I gotta write out my formula. A equals V minus U over T. Acceleration, A, I don't have a number for that yet, because that's what I'm calculating. I'm trying to work out my deceleration, which is a form of acceleration, so I don't have anything for it yet. Do I have something for my V, my final velocity? I do. It's 0 because in the question it said it stops. So my final velocity I know is 0 minus my starting velocity, 28, over the time it took for this change in velocity to happen, which is 8 seconds. So A is negative 28 divided by 8. Take out my calculator. 28 divided by 8 is 3.5, and that's going to be a negative value. So A equals negative 3.5 m slash s squared. So once again, because this is negative, your acceleration you see is negative, that's going to be a hint to you that that means it's a deceleration. So deceleration is 3.5 m slash s squared. I dropped the negative because I'm specifically saying it's deceleration now, so I don't need to keep the negative anymore. It's just I don't want you guys to do this calculation and then see that it's negative and think, oh my gosh, I made a mistake somewhere, can't work out where you made the mistake because there was no mistake, and then just give up on the problem entirely. I want you guys to be comfortable with the idea that you might be getting a negative value through the acceleration formula just from what the velocities are. Okay, so that's just the main idea. Don't get tripped up about the negative. Just know that you can have one and you haven't made a mistake. And then that's it. So that's my final answer. Let's do another example. I'll give you guys some time to do it yourself. The velocity of a car increases from 0 to 18 meters per second in 6 seconds. Calculate its acceleration. I'll give you 3 minutes to get started on this, and then I'm going to start doing this problem for you guys to follow along and check your answer. So give 3 minutes for you guys to have a go at this problem. Remember, make a list, formula, insert values, fine-tune, answer. Okay, let's have a go at this problem then. So, starting velocity is 0. Oops. End velocity, or final velocity, is 18. Time was 6 seconds. Acceleration equals question mark. My formula, A equals V minus U over T. So final minus initial over T. A is V, 18, minus 0 over T, which is 6. A equals 18 over 6. So that is an acceleration of 3m/s squared. So that is the final answer. Okay, so when it comes to this acceleration formula, it is a straightforward formula. So when it comes to calculations, I hope that in comparison to other calculations you've done, you find this a bit easier. The main tricky thing about the acceleration, where kids go wrong, where students go wrong, it is the most common thing I see is being tripped up over the unit and forgetting that the unit does have a squared in it, because some students then think, oh, I'm going to have to square root this 3 in order to get the acceleration. No, 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 no. You don't need to do that. You can leave it as m/s squared. That's just a unit for acceleration. The other mistake I notice that a lot of students make is when they read through the problem, getting the starting velocity or final velocity mixed up, or struggling to work it out from the question, such as if a question said it started from rest or it came to a stop, not clocking in that that means that the start or the final was 0. So basically just practicing those literacy skills, reading through the question and being able to extract the information from it. Okay, so now on to a bit of practice. Remember, this practice is optional. Don't feel like you have to do it. Also, don't feel like you have to do the whole thing if you do have a go at it. I'll link it to you, but on the website, oops, velocity, acceleration, by here, you should see a worksheet. That's just a bunch of practice problems. I will put up the answers to that in about 10 minutes time. Remember, feel free to skip through. Don't feel obligated to have to do all of them. It'd be great if you did, because in that way you have as much practice as possible. But remember, this is just for you and for you to develop your confidence in your skills when calculating acceleration. So don't feel like you have to do like every single thing. Just do what you can, try your best, and then at the point where you feel confident, maybe do one more to get as much practice done, and then, take a break. Right, okay, so next lesson we're going to be working on the next lesson we're going to be working on velocity time graphs. So we already did cover distance time graphs. Now we're going to be working on velocity time graphs. We should be finished with this topic this week, and then we're done. And yeah, so hopefully see you all soon. And I'll see you next stream. Answers will be up shortly. Bye.